Okay, let's try this problem again. This one is the most complicated one that I'm going to show you. So how much heat is required to raise the temperature of 100 grams of water from -5 degrees Celsius to 95 degrees Celsius? Here's what I need you to remember. So let's just go down here and jot this for a second. Here is a heating curve for water. Okay, remember solid, liquid, gas. This is melting. So when I go from -5 degrees Celsius to 95 degrees Celsius, the temperature is going to pause at 0 degrees Celsius for it to melt. So what I need to do is find the temperature, find the heat it takes to heat that ice from -5 to 0. Then find how much heat it needs to melt the ice. Then find the amount of heat it takes to heat it from 0 to 95. So I have 3 separate problems. So first, I do need Q, so I'm trying to write a little bit smaller for this one. Q equals MC delta T. So Q, MC delta T. Remember that's final minus initial. My mass is 100 grams. I had to have the specific heat of ice because if you notice on here, that's the specific heat of water, but I needed the specific heat of ice. So that is 2.03 joules per gram degrees Celsius. And I went from -5 degrees Celsius to 0 degrees Celsius. So final minus initial, 0 minus, oops, that's initial, minus 5 is 0 plus 5. So that temperature change was 5 degrees Celsius. Okay. Sorry, this is an I, very messy. So this Q is 100 grams, 2.03 joules. Remember, the per means it's on the bottom, gram degrees Celsius, and my temperature change is 5 degrees Celsius. So degrees Celsius cancels out, grams cancel out, I'm left with joules. So I have 100 times 2.03 times 5. What? Let's try that again. 100 times 2.03 times 5. Okay, so that Q equals 1015 joules. Let's leave it. So down here, that represents this heat right here. So 1015 joules, just this tiny piece. Now I need to find the amount of heat it takes to melt this, MHF. So my Q, MHF. My mass is 100 grams. My heat of fusion, remember, 334 joules per gram. So I do 100 grams times 334 joules. Remember, the per means it's on the bottom. Cross those out. So Q equals, real simple, 100 times 334 equals 33,400 joules. So if I go back to my diagram, that's the heat it took to melt it. But now I still need to heat it, this big chunk right here. So I need to do again, Q equals MC delta T. Let's see what I got for my variables. Remember, final. Hopefully I don't write it so messy this time. My mass, 100 grams. C, since it's liquid water now, I can use this. 4.18 joules per gram Kelvin. My final temperature is 95. My initial temperature is 0. So my delta T is final minus initial. So 95 minus 0, well, that's easy. 95 degrees Celsius. But I want it in Kelvin. Oh no, that's wrong for sure. Okay, but I want this in Kelvin, but I did this subtraction already, so if I wanted to change these to Kelvin and then subtract, the degrees, the delta T is going to be the same, no matter if I'm talking Celsius or Kelvin. So I would have to convert this to Kelvin and convert this to Kelvin to convince you. So let's do it. 95 plus 273 equals 368 Kelvin. This is 273 Kelvin, right? So let's do 368 minus 273. Look at that, 95. So that 95 is the change in temperature, but for Celsius and Kelvin, that number is going to be the same, okay? So it's going to be 95 Kelvin. Now I can plug it in. So 100 grams, 4.18 joules per gram Kelvin, remember? Then my delta T, 95 Kelvin. So Kelvin cancels out, grams cancels out. I'm left with 100 times 4.18 times 95. And that equals 39,710 joules. And that is this amount of heat, 39,710 joules. So look how much heat it took to melt it, a lot. So now what do? Well, I add those numbers up. So I had 1,015 joules. That was to go from -5 to 0. Then I had 33,400 joules. That was the amount of heat to melt it. Then I had 39,710 joules, and that was the amount of heat to heat it from 0 to 95. So now I'm going to add them up. So 1,015 plus 33,400 plus 39,710 equals 74,125 joules. That was a long problem, right? So a lot that I had to do, and the problem didn't really tell me that. But why did I have to do so much? Because I had to go again from -5 to 0, find that. Then the amount of heat to melt it. Then the amount of heat to warm that water. If I had gone beyond 100, say I had gone to 110 degrees Celsius, I would have had to go to 100. Then from 100 to 110 afterward, but I'd also have to find the vaporizing heat. So it would have been a lot more steps. So this was just 3, that would have been 5. I would have had to find this, then this, then this, then this, then this. That would have been a lot. So this is kind of the hardest type of problem you would see. So I hope that makes sense.